going to talk about parent functions in a general sense. The only purpose of this video is to be able to recognize parent function equations and possibly graphs and very, very simple properties. Now, there are lots of different families of parent functions. So one of the first parent functions, and the most basic one, would be a constant function, and its rule is f of x equals a constant. Remember that f of x is the same thing as y, so what this is actually telling you is that y is going to be equal to some number. You're going to end up with a completely horizontal line because y will have to be the same number no matter where I am on the line. Now, once you get a good picture in your mind, finding the domain and the range and the y-intercept shouldn't be too bad. The domain, if you remember, those are all the x values that this function can get to. Now, if you look here, I can go anywhere in the domain in the negative x direction, and I can be on the line anywhere in the or in the positive x direction, which means that x can be all real numbers. And just a reminder that that symbol does mean all real numbers. It's just a shorthand to say that x can be anything it wants. Now, the range talks about the numbers that y can be for the coordinates to still be on this pink line. And y numbers would have to go up and down. And you'll notice this line does not go up and down. It stays the exact same constant number no matter what. And that number is always going to be c. So the range for this is going to be y equals c. Now your y-intercept, that's still going to hit your y-axis. It's going to be the same exact number that y is, so this is also y equals c. Now the next family we're going to talk about is the linear family. And this is the most basic line that you can get. This is f of x equals x. Basically, x equals y. Whenever you're going to be looking at a basic linear function, you're going to be hitting the points 1, 1, 2, 2, 3, 3, negative 1, negative 1, basically where x and y are always the same thing. When you start to look at the domain and the range of this function, your domain, again, is all x values. If you remember that this is a line that goes forever, I can forever be positive x numbers, and I can forever be negative x numbers. I don't care how tall they are. I can go sideways. So this function also has a domain of all real numbers. Now the range. This time I'm talking about how high this line gets and how low this line gets. Now, I don't care how far sideways it is. I just want to know how tall it gets. And since I can go forever in both directions, the range of a linear family function is also all real numbers. Now your y-intercept, if we're talking about just your parent function, all I really want to know about is where it hits the y-axis, which is going to be always at 0, 0 for the parent function. Now, an absolute value function. This is f of x equals the absolute value of x. Now, the absolute value is by definition, the distance that x is between 0 and on a number line. And when you start to graph that as a two-variable function, you get y equals absolute value of x. Now this starts off looking very similar to the lines. As on the positive x-axis, I end up at 1, 1, 1, or 2, 2. Because absolute value of x cannot equal a negative number, I can't ever plug in a negative x here and get a positive negative y. So this graph basically bounces kind of like a mirror in this direction. So all absolute value functions are going to look like a V. Now if you're in your mind going, why? Remember, this is just a general overview. There will be a great amount of time dedicated to studying each one of these functions throughout this course. This is just an introduction so that you can say, oh, absolute value looks like a V. Now, if we're looking at domain and range again, domain, my x directions, I can still go for both directions forever in the x direction. So the domain is still all real numbers. Now the y, if I'm looking at the y direction, I am able to basically start here and it gets as tall as I want it to get forever and ever and ever. But my function stops dead right here when it gets to 0. What this means is that your range has to be a number that's bigger than 0. Y has to get to a positive number. So the range is just y is greater than or equal to 0. When we're talking about the y-intercept, this is going to intercept the y-axis the same way the linear one does. So we have it y-intercept at the coordinate of 0, 0. And remember, this is a non-transformed absolute value. Very basic absolute value function. Now the next couple that we're going to look at, we're going to talk about the quadratic function. Now the rule for the quadratic function, if we get fancy, we need to use f of x still. So we have f of x equals x squared. Now you'll notice that the exponents keep changing with all of these functions. That's how you can tell what kind of function it is. Now quadratic is a very basic parabola. Okay, kind of looks like a U. Little difficult, little difficult to draw with this, but I'm hoping you get the idea. Now, if we're looking at this parabola, it's not so much a V anymore as it's a little curvy. When we're talking about the domain and range here, the domain, even though it kind of looks funky, this parabola is going to keep getting wider and wider and wider the taller it gets. The x's will eventually go out forever and ever and ever. So I can still be at all real numbers for the domain. Now the range, this works just like in the absolute value function. The bottom of this parabola, which is known as the vertex, that is the lowest that this shape can get, which means that y also has to be greater than or equal to 0 for this function. And you'll also notice that it hits the y-axis at 0, 0, so that's going to be our y-intercept as well. Now the next function we're going to be looking at is a radical function. This is f of x equals the square root of x, also known as a radical. Now the quadratic function and a radical function are very similar. Well, not similar, they're related. Some of you might be familiar with the fact that the square root of x is an inverse with the square of x. Kind of in very loose terms means they undo each other. Now your radicals are basically a sideways parabola. Now I know my parabola does not look anything near that nice the first time, but if you took the blue parabola and just moved it sideways, you'll notice it looks just like the radical shape. Now I'm hoping you also noticed I didn't draw the bottom of this, and that's because in a radical function, I cannot have a radical that is a negative number. It just can't be. When we start doing that, we start talking about imaginary numbers, which again will be talked about, but not for a long time. So radical functions are only going to be this positive half of your function. And when you look at the domain and range on here, the x values that I'm allowed to be at here, the smallest x value that this graph is touching is going to be at 0, and then the arrow is going to go forever to the right, which means that the smallest number x can be a 0. So we've got a domain of x is greater than or equal to 0, because it can be 1, 2, 5 million, just something bigger than 0. Now when you're looking at the range, the same thing is going to happen to the range. Okay, the shortest that this range is going to be is where y is 0, and then this arrow, even though it doesn't look like it, it's still going to go up and up and up and up and up and up and up forever and ever. So we also have a range of y is greater than or equal to 0. I do hope you're noticing that this function has the same y-intercept that all of them do. It's going to hit at 0, 0. Now the last function is a cubic function, and we call that because f of x is going to be x cubed. Now x cubed is very similar to shape to part of a parabola. You are going to get something that looks like the positive half of your parabola, but an x cubed function instead of having two sides that go up so that I can have negative x's squared and get positive y's, when I have negative x's cubed, I'm going to get negative y's. Now what we end up with is basically this shape that looks like a snake. And at this point, I'm going to redraw that part. But at this point, that's all I really want you to understand is take a look at that cubic function and say, okay, it's snaking up and down the page. It's probably a cubic function. We will get more detailed later on. Now, based on this picture, the right arrow is going to keep going right forever and ever and ever, and I don't care how tall it is, but it's going to keep going right. The left arrow is going to keep going left forever and ever and ever. So the domain for this is also all real numbers. When you're looking at the range, I can be any positive y or any negative y and still be on this yellow function. So the range is going to be all real numbers. And once again, when you're looking at all of these functions, it goes right through the origin, so I have an intercept of 0, 0. Now, when you're looking at these as a whole type of unit, I hope you are noticing that there are some consistencies, especially with the range and the domain. If you look at these arrows, it's got arrows on both sides of the function that are going opposite directions, we're going to have domains and ranges that are the same, that are all real numbers. Now, whenever you have a function that looks like it's being stopped, that's when you're going to have to be very careful and look to see whether the range is at 0 or the domain is at 0. Another thing that all of these functions have in common is that every single one of them is going to go through the origin, except for the constant function, because it's not really going to have to touch at any specific y. It's just going to be, I can make c a 2 or a 7. Otherwise, all parent functions go through the point 0, 0.